Factor theorem of four polynomials. Determine if the quantity a minus 2 is a factor of 2a cubed minus 4a squared plus 7a minus 14. For our process, we will have here p, and we are going to put inside the parentheses the opposite sign of negative 2. This will be positive 2. And then we are going to substitute 2 to all the values of a for our polynomial. Let us now substitute. So we will have here 2. Instead of a, this will be positive 2 raised to the power of 3 minus 4 multiplied instead of a, that is positive 2 raised to the power of 2 plus 7 instead of a, that will be positive 2 minus 14. And then take note, if p2 will be equal to 0, then our a minus 2 is a factor of the polynomial. Let us continue. We have here p2, and this will be 2 raised to 3, that is positive 8 minus 4, 2 raised to positive 2, that is positive 2, that will be positive 4, plus 7 times 2 is 14 minus 14. p2, this will be equal to 2 times 8, that is positive 16, minus 4 times 4 is 16, plus 14 minus 14. Therefore, this is equal to 0. So since p2 is equal to 0, we can say that a minus 2 is a factor of the polynomial. This is our final answer for this problem. Factor theorem for polynomials. Determine if the quantity of x minus 3 is a factor of 2x raised to the 4th minus 4x cubed minus 4x squared minus 8x plus 6. For our solution, we will have here p, and we are going to put inside the parentheses the opposite sign of negative 3, and this is positive 3. And then we are going to substitute 3 to all the values of x. Substituting, we will have 2 instead of x. This will be positive 3 raised to the power 4 minus 4 instead of x, that will be positive 3 raised to the power of 3 minus 4 instead of x, this will be 3 raised to the power of positive 2 minus 8 multiplied by 3 plus 6. If p3, or if the answer to this will be equal to 0, then our x minus 3 is a factor of the polynomial, p3 So p3 will be equal to 3 raised to the power of 4. This is equal to positive 81 minus 4. 3 raised to the power of 3. This is positive 27 minus 4. 3 raised to the power of 2 is positive 9 minus 8 times 3, that is 24 plus 6. p3 will be equal to 2 multiplied by 81 is positive 162 minus 4 multiplied by 27, that is 108 minus 4 times 9, that is 36 minus 24 plus 6. So 162 minus 108 minus 36 minus 24 plus 6, this is equal to 0. So since p3 is equal to 0, we can now say that x minus 3 is a factor of the polynomial. This is our final answer for this problem. Factor theorem for polynomials. Determine if x plus 2 is a factor of 3x raised to the power of 5 plus 2x raised to 3 plus 25x squared plus 20. P and inside the parentheses will be the opposite sign of positive 2. This is negative 2. We will substitute negative 2 to all the values of x. Substituting, we will have here 3x raised to the power of 5. Since instead of x, this will now be negative 2 raised to the power of 5, plus we do not have here x raised to the power of 4. We will just put here 0. And then we have x raised to the power of 3. So substitute negative 2 to x. This will be negative 2 raised to the power of 3, plus 25. Instead of x, this will be negative 2 raised to the power of 2, plus, since we do not have here x, we are going to put here 0 plus the constant, which is positive 20. If p negative 2 will be equal to 0, then x plus 2 will be a factor. Will be a factor of the given polynomial. Let us continue solving. So p negative 2, this will be 3. Negative 2 raised to the power of 5, this will be negative 32. So this will be 3 multiplied by negative 32, plus 2 multiplied by negative 2 raised to the power of 3, this is negative 8, plus 25, and negative 2 raised to the power of 2, this will be positive 4, plus 0 plus 20. P negative 2, this will be equal to 3 times negative 32 is negative 96. Positive 2 multiplied by negative 8, this is negative 16. And positive 25 multiplied by positive 4, that is positive 100, plus 20. Negative 96 minus 16 plus 100 plus 20, this is equal to positive 8. So since p negative 2 is not equal to 0, x plus 2 now is not. So x plus 2 is not a factor of the polynomial. And this is our final answer for this given problem.